Today we're going to look at the last little part of our circles unit. We're looking at central angles, we're looking at arc length, we're looking at sector length. So a central angle, when we studied our vocabulary, a central angle was an angle that touched the center of the circle. So it was something like this. So here in our notes, a central angle is an angle with a vertex. Vertex just means bend at the center of the circle. And it's created by two radii or two radius. So radii is the plural of radius. So for example, if we look at this circle on the left, here is my angle. It starts at A, goes to B. B is the center of the circle, and then ends at C. That is a central angle because it's in the center of your circle. If you add up all of the angles in a circle, you end up with 360, or a circle has 360 degrees. Don't need this. So if we look at the arc lengths, so that kind of round symbol is the arc length. So if I look at the arc length of the circle on the left, they're proportional to the angle on the inside. So the amount on the outside also measures 84 degrees. So we have a small arc of 84 degrees. And now I want to know what is the measure of the major arc. So the minor arc was 84. The major arc is going to make up the rest of the circle. So a circle has 360 degrees in total. So all the way around is 360. And if your minor arc measured 84, we would find the difference. And so my minor arc measures 84 degrees and my major arc measures 276 degrees. So the big concept today is just a whole circle makes up 180. A whole circle is 360. Half a circle is 180. So if we look at these couple examples, and I'm not going to do all of them, we have three different sections in this particular example. We have a small section made up by angle RQS. We have our given section, which is SQT. And we have our semicircle, which is RQT. So because we have a semicircle, I know that this is going to be half a circle or it's going to be 180 degrees. Which means that this half of the circle also measures 180 because all the way around measures 360. So my green section measures 122, and if I wanted to find the blue section, I could say 360 minus my semicircle minus my green slice. That leaves 58 degrees left for my blue slice. And those central angles are also the angles on the outside of the circle as well. So these are just angle measurements because we don't have a radius amount. We're just looking at, this portion of the circle. So if I wanted the measure of ST, I know that that's 122. RS, we just found out to be 58. And SRT, that runs from S to R to T. That is my blue section and my orange section. So I can take my blue section, add it to my orange section, and I get that total value. So this particular arc, major arc, is 238 degrees. Sometimes we can see like flip-flop versions of slices. So for this particular one, I'm given this small green slice of 21. Well, that also matches the slice over here, which meant that that slice will also be 21 degrees. Well, I could go through and I could try to find the other two sections, but I do know that if I put these two slices of pizza together, I have half a pizza. Let me find a different color. If I put these two slices together, I have half of a pizza. So if I have half a pizza, if I have half a pizza, I have 180 degrees. Well, one slice of that is worth 21, which means the other slice is worth 159. And these sections kind of look opposite of one another. They form the X in the middle, so if one of them is 159, then the other one is 159. If we add up all of those slices together, we say 21 plus 159 plus 21 plus 159, you still end up at 360. So if we came over here and we looked at the options on the right, they want to know what is JK. Well, that's 21. JNM, we found out that's JNM, that section right there, that's 159. KL, so I'm just going to the letters, the measure of arc KL, well, that hugs the 159, so that would also be 159 degrees. JKM, so arc JKM, so JKM, are all three of those slices added together? So we say slice number 1 plus slice number 2 plus slice number 3, that gives us 201. And MKL, so I'm going to go to M, all the way around to K, all the way back around to L. Those are three slices as well. So if I add those three slices together, I get the measure of the entire arc. And that gives me 339 degrees. So that major arc is worth 339 degrees. So looking at central angles, it's just saying if the whole circle is 180, half a circle is if a full circle is 360, half a circle is 180, can we find those missing pieces? Number 4, that box represents 90 degrees. I do know that half a circle is 180, which means that this corner over here must also measure 90 degrees, and this corner over here must also measure 90 degrees. Notice that the 34 is this slice of pizza. So it's 34 degrees on the outside arc, then it's also 34 degrees on the inside. So it's very easy for me to come in here and find the blue slice of pizza because I have everything else. I can come in here and I can say, hey, I had a whole circle of 360. Let me take away the first corner, the second corner, the third corner, and that small green slice of pizza. That leaves me with only 56 degrees, and then I can find all of the outside arc lengths as well. 59 degrees, 90 degrees, 90 degrees, 90 degrees. Then once you have them all, you can find those combinations. When you understand the concept, if we turn the page over, we can look at when we include variables. So for example, look at letter 8. If I compared this slice of pizza with the other information that we're given, that's this slice of pizza, we can say, hey, those form that letter X. They look like flip-flop versions of the pizza. So if those are literally flip-flop versions, then they have to be the same size. So we can come in here and create an equation that says, hey, these two slices are the same exact size, and solve for that missing side. Or solve for that missing variable. Looking where they crisscross. So my X value is equal to 17. If I wanted to find this, I could plug the 17 in. I could get a value. I could then use that to find missing values, different, parts of the circle. It also works with ones like number 9. If I look at the information that I'm given, and I compare them, well, these two slices, if I look at them, they make half of the pizza. So if I had a blue slice and I added it to a green slice, I would have half a pizza. So my blue slice is worth this much, and my green slice is worth this much. And that's why I like using the colors with different kind of like arcs and sectors, as you can see that if you just add the blue to the green and then go in and fill in your numbers. We can come right in Desmos. There's that equal sign. So once you see an equal sign, you can put it in Desmos where you say y equals the left side of the equation. We're going to type it in just like we have it written. Y equals the second half of the equation, which is 180. And we do see where they crisscross. X value is 9. If I wanted to know this side, I could come in here, plug it in. I could plug it in here. So my blue slice of pizza, once I know the value for X, is 68. And my green slice of pizza measures 112. So I know that this one measures 68 and this one measures 112. So it's just kind of looking at those characteristics within the circles. Well, part of that comes in the form of arc length. So arc length is when we say, if I have a central angle, okay, and I know the radius, so I'm given just a little bit more information, can you come out here and tell me how much is this worth, this arc length? In terms of our pizza, this would be like saying, how much crust of our pizza do you currently have? So if we're looking at our circumference represents our crust, circumference represents the outside edge of my circle. So when I look at arc length, I know that I'm dealing with circumference. So my circumference formula was twice my radius times pi. Now, the deal is this arc is not the whole circle. It's not all of the crust. It's just a portion of the crust. So the whole pizza is worth 360 degrees. We're looking at our portion. How much do we have? Okay. So if I look at my formula, then I'm looking at how much belongs to me. And am I looking at the crust or am I looking at the slice of pizza? So look at example number 1. Example number 1 is asking you for this section of the pizza. This is what you currently have. This is your slice of pizza. So when I look at this, I say, well, I have 107 degrees of that pizza. That belongs to me. There are 360 in total. 107 of them belong to me. I am looking for the arc length, which is the crust. So twice my radius times pi. So here's that 2r pi. There's your crust. Okay. So we come right in to Desmos and we say, let me clear this out. I have 107 degrees of the full pizza, and I'm looking at the crust of my pizza. So I put it in 2 pi r, and I come out with 11.2 meters. That is this arc length. So we're just looking at how much, if we measured it, are we talking about? So we look at number 2, we're looking at a smaller slice. So if you have a small slice, you have a small part of your crust. And we are allowed to have 38 degrees out of the whole pizza. That belongs to us. That is our portion. We are looking for the crust of the pizza, which is 2r pi. So I'm looking for twice my radius times pi. So if this is what I'm allowed to have, then when I evaluate it, 2 times my radius times pi, I have 9.9 inches of crust. That means that this outer edge, if I was to take a tape measure to it, would measure 9.9 inches. Look at example number 3. This is a really good one to throw a set of looky eyeballs on, because this is asking you about this major arc or this major sector. This section of the pizza that I'm highlighting in blue is what you are allowed to have. That's your part. That's your section of the pizza. The problem is that this 142 represents the white area, not the blue area. So we have to figure out how many degrees belong to just the blue area. So if the whole circle is worth 360 and the white section is worth 142, that leaves 218 degrees for your large blue section of pizza. So once you know your degrees, you can say, well, I'm allowed to have 218 degrees out of my whole pizza, and I'm looking at just the crust. So my radius for this pizza is 4 centimeters. When I go in, I can now evaluate how much space or how much crust does this particular section of the circle cover. And that is 15.2 centimeters. We'll skip these questions. Number 4 is very much like number 3. So they're looking for this small blue section. But again, that 288 belongs to the white section. So you have to figure out the difference. What's missing? What's the missing piece? I want to go down to these application questions. So like number 11, a 16-inch pendulum. Pendulum is like a long metal rod. And what it does is it just swings back and forth. So it just swings back and forth and back and forth and back and forth. like this. So we could just something that swings back and forth, like a swing on a playground. It says the 16-inch pendulum swings through an angle that it measures 40 degrees. How far does the tip of the pendulum travel in a single swing? So it's asking how much did it travel when it swung? So again, this pendulum is 40 degrees out of the full circle. That's all it's moving. And we're looking for the outside edge. So 2 times 16 times pi. So 40 divided by 360. 2 times my radius times pi. So every single time this pendulum swings, it moves a total of 11.2 feet. So again, all you're looking at is what portion can you claim? So this is the portion that I claim, and what are you evaluating? Are you evaluating the circumference? Are you evaluating the area? So we're going to do a couple that are in area. Before we do have to talk about something called a radian. So circles are special because they come in both degrees, and you can measure a circle using pi. So for every circle, it contains 2 pi's. And so sometimes we have to go between the two. I prefer to always use 360 and 2 pi. It's less to memorize, it's less to mess up. So a full circle contains 2 pi's. So it's like when you travel outside of the United States. Believe it or not, the American dollar is not taken in every single country. If you go to a different country, you have to convert your American dollars into whatever country you're visiting. So if we were going to Europe, pick a country in Europe, if we were going to Spain, we would have to convert our dollar bills into euros. And so they carry a different value. Well, in a circle, it's like converting between degrees and radians. You have to see what are the equivalent values for both. What I always use is a proportion. I try not to do crazy math. I try to keep things very simple. So I will always compare 360 degrees and 2 pi. And I will ask, well, up here, we're going to keep degrees and we're going to keep a pi. So it just depends. How many degrees do you have? How many pi's do we have? So if we look at question 4, we have 30 degrees. So it's 360 degrees for every 2 pi. 30 degrees, I want to make sure it stays aligned up with the degrees. So 30 degrees. I want to know, well, how many pi's is that? The reason I like a proportion is because there's that equal sign, which means that we can solve them in Desmos. So I say y is equal to 360 divided by 2 pi, and y is equal to 30 degrees divided by some other pi. So we're going to keep them proportional. And now all we have to do is look where the two values intersect. It's right up here. I'm just zoom in really big. So 1.6667. I know that that's just a repeating 6. The reason I put it in this way is because now you have a fraction that pops up. So pi's are usually written in fractions. So 1 point, a lot of 6's, that comes out to, oops, I put a 1 in here. I shouldn't have put a 1. There we go. Put my 1 in the wrong spot. There we go. So make sure that my decimals are matching. And it turns out to be 1/6. So 30 degrees is the same as 1/6 of a pi, or some people might write that pi over 6. If we look at 150, We use the same proportion. 360 over 2 pi, that has to be the same as 150 degrees over how many pies? So we come in here, we can change this one. Say 150 over how many pies? We look where they crisscross, 0.83333. So I'm going to come in here, 0.833333. Lots and lots and lots of threes. That fraction bar comes back up. We click it, 5/6. So 150 degrees, is the same as 5/6 pi, or you might see some people write it as 5 pi over 6. You still do area with that. You still do sectors with that. You still do circumference. You can still do all kinds of things. Sometimes we measure in degrees, sometimes we measure in pies. Let's do number 7 where we kind of go backwards. I want to compare my degrees to my pies. Well, this time I've got a pi in my value. So I'm going to put it down here with my pies. I know it looks strange because we're not used to fractions divided by a fraction. So I have pies compared to pies, and now I can compare degrees to degrees. So I come up in Desmos and I say, okay, how many degrees is, and I like to keep, my fractions wrapped up together, 4 pi over 3. So that this looks like what I've written in my notes. I look where they crisscross, and they cross at 240. So I can say 4 pi over 3 is the same as if I was using 240 degrees. The last thing I want to talk about is something called a sector. A sector is a portion of the circle, and we don't care about the rest of it. It is your pizza slice. How much pizza do you have? How much belongs to you? So again, it's a portion. So we're going to say how much of my pizza, and because we're looking at area, area is pi r squared. So just like when we were looking at circumference and looking at the crust of the pizza, now we look at the pizza slice as a whole. So if I want to know how much actual pizza do I have 51 degrees out of 360. That is my part of the pizza. They told us that BC was 16. So now I can say, okay, well, I have 51 degrees of my pizza, and I'm looking for the area. So times pi 16 squared. So come back, use Desmos, let Desmos do all the dirty work. It will do all the number crunching. You just have to set it up correctly. So pi times my radius squared. So I have 113.9 square feet of pizza. That's a lot of pizza. Let's try number 4. Again, very good one to write the word look. Because your slice of pizza is not 126 degrees. The 126 belongs to the white section of your pizza. So if a whole pizza measures 360 and the white section measured 126, That means that the blue section measures 234. Now we can come back and say, well, 234 degrees of that pizza belong to me. That's mine. And we're looking for its area or sector. So pi times my radius. They told me my radius was 13 squared. So 234 divided by 360 times pi times my radius squared. So I have 345.1 yards squared because it's area. So it's not too challenging. Again, everything that has to do with portions of a circle, you just want to say, what am I looking at? Area or circumference? And then what portion belongs to me? That portion can be out of 360 degrees, or that portion can be out of 2 pi. It depends on, what you're measuring your circle with.